Hi, my name is Sophia. Today I'm going to be talking about horizontal projectiles. The main theme of horizontal projectiles is to keep them separated. And by I mean the vertical part of the equation and the horizontal aspect of the equation, because those two things are independent of each other. So the vertical, there's two equations that we use for horizontal projectiles. The vertical equation is this one, where x is how high or in meters the distance is. Half A is gravity, which we always assume is 10, and then T is time. And then for the horizontal, it looks like this. X is the distance traveled is the horizontal distance. V is velocity, and T is time again. So today I'm going to talk about Bob. And Bob has just made a parachute, and he wants to see how far his parachute can launch off of a 75 meter, building. So he climbs up. Here's Bob with his parachute. I don't really know how to draw a parachute, but that'll do. Kind of looks like a mushroom. And he launches it at a velocity of 12 meters per second, all the way down. And we want to find out where horizontally the ball will land. So we want to find the range. So using this information, we're going to first start with the vertical equation, which, if we can remember, is x equals half AT squared. This is the vertical. And with the vertical equation, we'll be able to find the time, which we will then plug into the horizontal equation. But first, using the information we have, x we know is 75 meters, so we can plug that in. 75 meters equals half A, which is gravity, so 10 meters per second times T squared. So we solved that through 75 meters equals 5 meters per second times T squared, divide by 5. 75 divided by 5 is 15 meters equals T squared. Take the square root, and we get T equals 3.87, so we can round that to about 4 seconds. Okay, so now we know that the distance, or the amount of time that the parachute is in the air, is 4 seconds. So we can now plug 4 seconds into a horizontal equation. Use a different color for this one. So this 4 seconds can be plugged into this equation in the horizontal. X equals V times T. So X is what we're looking for. We don't know what X is. V, if you can remember, is the 12 meters per second that it is originally launched at. So this will be 12 meters per second times T, which is 4, which we just found. Or we're rounding a little bit, but 4 seconds. So we multiply that out and we get 48 meters. So now, going back to this, we know that the parachute will land at 48 meters on the ground. And that's it. Thank you.